So now that we've been talking about constitutional isomers, one of the things you may be asked to do is to draw all of the possible constitutional isomers for a given chemical formula. And this can take some doing, and we need to have a systematic approach for going through these to make sure that we're getting all of the isomers. And hopefully we're not going to repeat ourselves during this process. But if we do, we need to be able to recognize when two of the molecules are the same. I'm going to break this apart into two videos because, well, I chose a bigger molecule and it has a lot of isomers, and I don't want this video to be too long. So it is useful to find the degree of unsaturation for a molecule. So I'll just mention that. I chose C5H10Cl2. And this particular molecule is fully saturated. And we know that because if we take 2 times 5 plus 2 should equal 12. Well, like I said before, the chlorines can kind of substitute for hydrogen, and so we have fully saturated. So let's start off by drawing out the possible ways that we could draw the carbon skeleton. So one way that we could draw it is just a straight chain. Another way that we could draw it is with a single methyl group. And then the last way that we can draw this is the neopentane with 2 methyl groups. And these are all the possible isomers of C5H12. But I added chlorines onto this. And so now we have to put 2 chlorines on this structure and look at all the possible ways that we can do that. We'll start with the straight chain, then we'll move on to the branched ones. So to systematically do this, I'm going to start by putting one of the chlorines on carbon number 1. And I will put the second chlorine on carbon number 1. In the next structure, I will keep one of the chlorines on carbon number 1, and then I will move the second one to carbon number 2. And I will repeat this process until I've moved the chlorines all the way down the chain. So I have on carbon number 1, there's 2, so now 3. And now we get to put it on carbon number 4, and then carbon number 5. Now, you might think, oh, we're done. Well, no, we're not, because there are isomers where one of the chlorines is not on carbon number 1. Now, we don't have to draw the one where one of the chlorines is on carbon number 2 and the other one's on carbon number 1, because we already drew that one, right? So now we'll start with them both on carbon number 2, and then we'll move on down. So now we have 2,3-dichloropentane, 2,4-dichloropentane, and you might think, oh, well, we could have a 2,5-dichloropentane, but no, we don't, because that would be properly called 1,4. And we've already drawn that one. And when I was drawing these all out, I mistakenly drew it, and then I thought, wait a second, I think I've drawn that one already. But I'll show you what I mean here by drawing it. These two are the same. That's what I mean. We would just count this from 1, 2, 3, 4 rather than 2, 5. Remember our nomenclature rules. And actually looking at some of the names, because one of the ways I figured out, oh wait, that's the same thing, is by thinking of the name. And I realized, wait, that one would have to be carbon number 1. I've already drawn that one. And so that's another thing that you can do, kind of think about. And then we could have both of the chlorines on carbon number 3. And again, for the same reason, if we were to put one on, say, carbon number 4, well, that's actually carbon number 2, and that would be the same as this one. So we don't have to draw that. And 3 and 5 is actually properly called 1,3. So we're done with all the possible combinations of the straight chain. Now we have to repeat this moving around the chlorines for the branched chain. Draw a few out. Again, I'll put them on carbon number 1. I know this is carbon number 1 here because even in the name, we would call this 1, it would be 2-methyl, right? So this would be the first carbon. Okay, so 1,1-dichloro, 2-methyl butane, right? Chlorine on the first carbon, chlorine on the second carbon, still possible. Now that carbon has 4 bonds to it that are non-hydrogen bonds. So we have 1,2-dichloro, 2-methyl butane. We can put the other chlorine on the substituent. So we're going to have a little bit of a symmetrical molecule there. We can put the chlorine on the third carbon. And we can put it on the last one. So I think that's all of the isomers that include the chlorine on the first carbon. Now we could have the chlorine on the second carbon. We can't put both of them on the second carbon because that would make that carbon have more than 5 bonds, or more than 4 bonds. It would have 5 bonds. So that's not allowed. But we can put it on the third carbon. And we can also put it on the last carbon there. Put them both on here, which would now be the number 2 carbon, but slightly different there. Let's see. I could put one here and one there. And then I can also put both of them on this other carbon here. which would now put them both on the first carbon, because that would not be the new first carbon. Okay, we're almost done. There's just a couple more to draw. So we have the neopentane, and we can either put them both on one of these, the same perimeter carbon, or we can put them on different carbons. There's no room on that central carbon for anything else because it already has 4 bonds. And all of these carbons are identical, so it really doesn't matter which ones we put it on. Any other structure that we draw would be the same. So that's how to draw all of the constitutional isomers for C5H10Cl2. It's best to go through with a systematic approach. Try drawing out all of the possible carbon backbones that you can have, and then systematically move through by moving the substituents around. You have to go in this with a plan, because if you don't, you are very likely to miss at least 1 or 2 isomers. So with that, thank you for joining me for this video, and we'll see you in the next one.